Right, good morning. This is our science lesson in my kitchen. Today's lesson our learning intention is to understand how investigating in science can help us explain the living world, and also to understand how scientists work using the scientific method. So the big question today is what do plants need to grow? So I'm expecting that, among other things, children are going to say maybe sunshine, fresh air, and hopefully water, because water is the focus for today. So how do we know the plants need water to live? How do they drink water or absorb water? And what can we observe or use as evidence to explain this or to justify that plants do drink or absorb water? Where do they absorb this from and through what part? So we want children to get to a place where they understand that the water comes usually up from the ground, up through the roots, through the stem, and to the leaves and all of that. So then we also want to expand that discussion to where does this water come from? How does it get underneath the ground? And maybe just have a quick look at how when we put water down the drains and the gutters and into the waterways, that actually goes back into the ground and it's absorbed by the plants. So then maybe the chemicals that we wash down the drain or in the gutter from industry, even things like washing your car on the road, those soaps and chemicals and things will go into the drainage systems, they'll go into the ground, and the plants will drink that up again. So does that affect the plants as well? Do children think that? So just to kind of get their thinking going around that and asking questions and looking at what things would we observe about a plant if it's growing really well, if it's getting clean water, or if it's getting poisonous, like toxic water, and then is it still growing well or not? And maybe we could link that to us as humans. Do we drink clean water or would we drink bad water? And what would maybe happen to us if we drank dirty water out of the gutter? So just to kind of get their questioning going and to get them excited and interested, that's the, introduction and motivation for the lesson. So once we've established all of that, we're going to explain that we're going to do, I'll explain that they're going to do an experiment and explore some questions that will help us to better understand how plants drink water and using the scientific method. So we're going to use this little poster here about the scientific method and do an explanation about scientists ask questions, which is what we've actually started with as well. They research the topic, so we have a good think about plants and how do they work. We have an understanding of how plants work and the different parts of the plants and what plants need to live. And then we're going to make a guess, which they're going to do when they start the experiment, and then we're going to test it, we're going to analyse the data, and we're going to report the results. And through this whole process here, we're going to focus on using lots of questions and observations. So making sure the children understand what observations are and obviously what questioning is, so that as they work their way through this in their little groups, they can actually record all of that information. So I have here the 3 glasses. I'll just adjust this little thing, lower it down. Let's see. So I have these 3 glasses, and I'm going to do the first one. I'm going to just say, what do you think would happen? So I've got 3 plants in here. Just make this so you can see it. And they all have water, and you can see that the stem is in the water so that they can drink it. What do you think would happen if I put some food colouring in there, as blue, and we're going to wait and see what might happen that might be able to explain how the plant is actually drinking the water. So every group is going to have 3 glasses, 3 plants, and you have 3 different colours of food colouring, and we're going to use these question dice, which imagine I've folded them up very nicely, and we're going to have a think about how might this explain to us how plants drink water over time if we observe this. What can we describe about it? What changes might we see? We can make predictions about what might happen. What do you think could happen now that I've put blue food colouring in here? Is the plant going to drink just the water or just the food colouring, or can it separate the two? Is the food colouring going to be good for the plant or not? How do we know that? So children are going to have their little groups in their food colouring, and they're going to go away and ask some questions, make some predictions or a hypothesis, and then we're going to test the hypothesis. We're going to record the observations and the results, and then we're going to come back. Now you may want to do just one, and then we can observe it again tomorrow before we actually do the next one. So they all have pretty much the same amount of water. We could measure the amount of food colouring that we put in there. We could do different colours, or we could do just different amounts of food colouring. So we could put like 2 spoonfuls in there, 1 spoonful in there, and maybe half a spoonful in there, and see what happens to the plant. What's the effect on the plant? Some children might, instead of writing the scientific method responses down in your book, you might want to just get your devices and just do a little video recording. And it's important that when we're working in little groups, that we make sure that we have a person who is the recorder, or the person who writes things down in your book. Maybe choose the person in your group who has the best handwriting. We need someone who's a materials manager, so they can collect the bits and pieces and take care of them and return them safely to me at the end of the session. And somebody who's maybe the photographer or person who takes pictures, just to evidence your work as well. So I've already arranged the groups, and they're mixed ability groups to ensure that every group has somebody who is sensible and responsible and can pull the group together, and children who are interested in science and maybe those who are not, so that it's a nice balance within each group. So some of the key questions we're going to make sure that I ask, that I've written up here on the board, are: how would you describe? Can you explain? If we changed ... would the ... and will the same thing happen each time we... and then there's a question mark. So in my plenary, obviously this is going to have to happen over a few days. Might need to be a couple of short little sessions over a few days, and observe the changes in this one, and then decide what they want to do with the next one, and then the following day, maybe having observed these results, they will decide what to do with the last one. So this is probably a bit of a drawn out science lesson, not just a all-in-one kind of snapshot. The plenary I've listed down as what if we learned about the way that scientists carry out their work? So I guess it's like a reflection or appraisal of this method, and how children have found that helpful or interesting, or what challenges they had with it, or how it's helped them to understand how scientists work. And then the other question is, what have you learned about how science and investigations can help us explain the world around us? So I'm looking there for what children can, how they can make connections from what they've learned from this, and about how these plants have absorbed this water, and then link that to what does that mean in terms of the living world, and how do they link that to the water that we drink, and how that affects us and our actions, and how our actions impact on nature. So that what we're putting into the water cycle or the water table, how's that impacting on the plants, so that they can link that connection there with their actions and their choices and the impact on nature. So that's my science lesson.